Okay, so today we are going to talk about the challenge problem on the chapter 9. So the first question is, so we have the two inequality. So we separate them. The first inequality is this one greater than 2r minus 4. Then for inequality, we can both keep like a balance scale, right? I mean, we can shift and move, make a equal change on both sides. It doesn't change the sign. So now we can move the r here. We can subtract r, and we can plus 4 here. So then we have the plus 4 here minus r. So we have 11 greater equal than r. And the other side is the r plus 7 is less than 3r minus 15. So we get is 2r greater than the 22. So we have the r greater than 11. So we have r should be greater than 11 or less or equal than 11. So there is no such r existing, right? So no solution. Okay, number 38. So we can do x squared. We can take out 3 on both sides. So less than 3 is equal to 9. So x squared is less than 9, right? So x should be greater than negative 3 and less than 3. Next, compare with this. So when we compare the numbers, we only know the a of the x is, for example, a is greater than 0, right? The a of the x is less than b of x if a less than b. Or we know if 0 less than a less than 1, then we have the a of the x is less than a of the y if x greater than y. And if a greater than 1, we have the ax greater than a of a to power to the y if x greater than y. Okay, so now we need to either to move the base the same or the power the same, right? So for this one, so we can see the 46 is 2 times the 23, so it's 3 to the 2 of the 23, and compare with the square root of 82 of the 23. Then this is 9 is square root of 11 of the 23. So now we know this one is this, right? So this one is larger or bigger. Okay, so next, okay, for this problem I will talk about some how we find the linear maximum value in a bounded region. Okay, so basically the problem is a general problem will be like this. For example, if we say we bounded like by some lines, for example, this is the y equals x, and we have another line is like this. It's like this. Okay, so it's for example, this is y plus x equals 4. Then we need somewhere is less than this, some area less than this, and also less than we need some area of the less than means the y. This area is y less than 4 minus x, and this area is y also less than x, this one over this one, right? And also we need the x greater than equals 0, y greater or equals than 0. Okay, so all these conditions combined with this region, right? Now we want to find, for example, we want to find the maximum value of the 2x plus y. Okay, let's see how we can do it. So 2x plus y, let's see which one equals c, right? So we can have a y equal negative 2x plus c. So we can see if c is 0, right? So this line is something like this. Right? This is a 2x plus y equals 0, right? So the 2xy plus c is moving is the parallel is a set of parallel lines, okay, and moving on this region, right? So what we want to see is which one can make the 2x can make the have a biggest y-intercept, right? Because c is the intercept, c is the y-intercept. So of course we need to bound it on this region, right? This is the region we are moving. So with a set of cutting lines, so we can see when we move to here, right? This line can causing the biggest of the c. So that's why when the line is when the line passing the x equal 4, when the line passing through the 4 and 0, right, it's the c. So let's put the 4 and 0 inside. So it's 0 equals the negative 2 times 4 plus c. So we know the maximum of the c equals 2x plus y is equal to the 8. Okay, so this is a general problem. This is how we solve the linear maximum of the linear combinations if given the bounded region. Okay, now let's see this problem. Okay, so let's digest the problem first. Okay, so we have the 180 hours. Okay, so I can which I play the video game or watch the movie. So there is a game or there is a movie. Okay, the total is 180. This is the hour, and each movie lasts 2 hours. And each game lasts 20 hours, and I have the $600 in total, right? So each movie costs $10, and each game costs $40. Okay, that's what we can digest. If we make 3 new friends for every time for a video game, okay, this is a friend, F. We have 3 friends for every game, and we have 1 new friend for every movie, right? So how many movies should I watch this year to maximize the number of the friends I make? Okay. So this is the bounded problem. So now let's see. Okay, so let's assume we have X games and the Y movies. Okay, so we have the 20X plus the 2Y, because we only have 180 hours, right? Should be less than 180, and we have the 40X plus the 10Y should be less or equal than 600, right? So what we want to try to maximize is the number of friends. So 3x plus y is what we want to maximize, right? That's C equals C. Now you can see this problem is we can put it on the coordinates graph, right? Okay, let's put on the coordinates graph. Before we put it on, let's simplify a little bit. So this is the 10x plus the y is less than equal than the 90. And this one is the 4x plus the y is less or equal than the 60. So let's see, let's use the 10. So it's 10, 20, 30, 40, 50, 60, 70, 80, 90. So here this one is 10, 20, 30, 40, 50, 60, 70, 90. Okay, so the 10x plus y, right? So x equals 0, y equals 90. So this is 0, 90. And y equals 0, x equals the 9. So 9 is somewhere here. So the first line is this is the first line. So this is the 10x plus y equals 90. Right, so we need to less than, so it's in this region. So the second one, okay, so 4x plus y equals this. So y equals x equals 0, y equals 60. 1, 2, 3, 4, 5, 6. Y equals 60, and y equals 0, x equals 15. That's here. So we can have okay, so this is the 4x plus y equal 60. Okay, so we have a region is here. So we need our less than region is somewhere here. Okay, now let's see. We have the k of this one, the slope is negative 10, and the k of this one is negative 4, right? Okay, so the k of the 3 should be more flat, right? Is somewhere here is the k of the 3. If k is negative 3, so let's see, okay? So when we're cutting through all this region, right? So x and y should be greater than 0, right? And integers. So we are cutting this one, right? So we should moving somehow to this point, right? Because when we move to this point is when we move to this point is somewhere here, and we can still move to this point, right? This is the point we can move in, okay, to maximize our point. So this point is what? This point is basically the intercept of the 4x plus y, intercept of the 4x plus y equals 60, right? So now we can see, okay, so the max, okay, should parsing the point of 0 and 60. Okay, let's see what's that. So 3 times 0 plus 60 equals C. So maximum of the, this is the question, answer to problem A. So 3x plus y equals 60. Okay. Next. B. If I instead make 5 new friends every time I get a new video game, but I still make 1 friend per movie. Okay, how to? So if we want to, for the B, if we can do 5, right? So that means we are trying to maximize the 5x plus y equals C. So we try to maximize the 5, right? So the 5, the slope will be steeper, right? So it will be something like this. Okay? So now let's see. If we do the 5, so see if we do here, basically we're passing inside this line, right? So if the 5, we should go to the intersect of these 2 points. Let me use another color. If the 5 should be here, this, if the 4 should be here, okay? I'll let you see. This is the first one. This is the second one. So you can see the 5, if I pass in this point, the intersect is higher, it's bigger, okay? Yeah, so now let's solve the intersection, okay? So the intersection is basically we need to solve this set of equation, right? So from here, 4x plus y equals 60, and 10x plus y equals 90. So we can know x equals 6x equals 30, so x equals 5, and y equals 40. Okay, so the 5 and this line, maximum line should pass in this point, means the C max in this condition should pass in 5 times 5 plus 40 is equal 65. Okay. Okay, now what's the last problem? Last question is, suppose I want to make as many as friends as possible, and what is the smallest whole number of the friends each new video game must give? To assume I make the same number of friends for every video game I buy in order to make sense for me to buy video games only. Okay, it's still, we have the bounded region here, right? So the bounded region is like, it's like this, okay? So the slope here is minus 10, the slope of this one is minus 4, right? So we want to, okay, we want to make this maximize, right? At the point to make all the video games, right? So that's why we want to the point, the maximize point, okay, to be on the x, right? We want the maximize point to be on the x as much as possible. So what is the largest x point? That's here. Okay, so you can see we want our maximum point happens at x, right? So if we are kind of flat, right? If you think we are kind of flat, see, if we're passing this point, it's here. The point C is here. If we're passing this point, C is here. If we're passing this point, C is here. So if we're too flat, we go to here. if we should be much deep, right? And then we can go to here, like here. The maximum point it takes here, right? So that's why our k, in order to max point at x axis, okay, so we need slope should greater than, the slope exactly should be greater than 10, okay, greater or equal than 10. So that means we need at least 10 friends for one video games. Okay, so that's it about this problem. Okay.